Hi, and welcome back to the second video here of exponent properties or exponent rules. So just to kind of do a quick little recap here of the first video, we really dealt with talking about the product property and the quotient property. So we have still the power property, which is really like three mini properties together, and then we have some other kind of like smaller ones, the zero exponent definition, and we also have to talk about the negative ones. So we really went in depth with the product and the quotient properties, and so now let's talk a little bit more about the zero exponent, which is fairly straightforward. So basically anything to the power of zero is 1. Any base at all whatsoever. It could be a variable like x to the 0 power is 1. It could be a base, any base. It could be a negative base, -4 to the 0 power, that's also 1. It could be a really huge base like 1479 to the power of 0 is also 1. No matter what it is, no matter what the base, as long as it's raised to the power of 0, it's 1. So it's a pretty straightforward one. Now, one of the power properties of exponents is dealing with whenever you have a division inside the parentheses. And that's being raised to the power. That means to say everything inside the parentheses, whether you're multiplying or dividing, is also going to be raised, meaning to say that the numerator is going to be raised to the m power and the denominator is going to be raised to the m power. So it kind of breaks it up. It's almost like taking this m and splitting it for both of these, raising both of those. Both of those are going to end up with m's, which is what you see in the mathematical notation. So what does that look like? Well, here, and we're going to skip that one actually. Let's take a look at that one. Those other ones aren't quite as helpful. But really what we're saying here is we're taking, you see, everything's being raised to the 4th power. So everything in there is being raised to the 4th power and everything down there is being raised to the 4th power. So really we're taking 2m to the 2nd power, and then we raise it to the 4th power, and then we take everything in the denominator, 5n, that's also being raised to the 4th power. And we'll come back to some of these other examples, but first we need to talk about when we have a power to a power. So basically when I have something that's being raised to that exponent and then being raised again, we are just multiplying essentially the outer exponent and the inner exponent. And what that would really look like is, say for example I have a to the 2nd power, and then that's being raised to the 3rd power. Well, what am I really raising to the 3rd power? I'm really taking a times a, and I'm raising that to the 3rd power. So really I'm doing a times a once, a times a twice, a times a 3 times. So how many a's total? 1, 2, 3, 4, 5, 6. So instead of having to do kind of this whole thing, I can just go straight to saying a to the 2nd power times 3 is equal to a to the 6th. Okay, and that would be the exact same thing. And then similarly for the next power property, is if I were to kind of have two things multiplied together, just like if I had two things being divided, I can actually grab that exponent and almost like raise both of the things to that exponent. Okay, so what that would look like here is I have y to the 5th power, and then I have that raised to the 9th. So same thing, what I would take is really saying y to the 5th power times 9. For A. And that would really just say y to the 45th power. And for B, we're really taking 4 to the 4th power to the 7th power, which is really just saying 4 to the 4th times 7, which is 4 to the 28th power. Okay, so now the next example is where we have, so for part A, we're doing -9 times d and that's being squared. So really what I'm doing is I'm taking that 2 and raising the d to the second power, and I'm raising the negative 9 to the second power. And that negative 9, keep in mind, is also going to be in parentheses. Okay, so then we have d to the second power. Now, negative 9 squared can actually be calculated. That's 81d squared, and that's your answer. Okay. All right, part B. So part B has 3 things inside my parentheses. I have 3, I have m, and that's being multiplied by n as well, and that's being raised to the third power. So I'm taking that 3, I'm raising the n to the 3, the m to the 3, and the 3 to the 3. So 3 to the third times m to the third times n to the third. And really 3 to the third is 27, m cubed, n cubed. And so that would be your answer. So notice everything is being raised inside of the parentheses. Okay. So let's take a look at the next set of examples. So for A, we have y cubed, and that's being raised to the 6th power times y to the 5th, and that's being raised to the 4th power. So we can go ahead and multiply these together. Okay, so I have y to the 3rd times 6, and then I have multiplied y to the 5th times 4. So that would end up being y to the 18 times y to the 20. Now wait a minute, I have the same bases here, so I can actually use the product property as well. I can say, well, I can rewrite this as one base, and then I can do 18 plus 20, and that's going to end up giving us y to the 38th power. So now we're combining not just power properties, but also product properties. So all of these things are super important because they all tie in together. So that's part A. Okay. Part B, and I don't want to go actually so far down. Part B says, okay, well, I have negative 6 times x to the 4th times y to the 5th, and all of that is being raised to the 2nd power, which means every single thing is going to be raised to the 2nd power. So I have negative 6, and that's being squared, times, and again, I'm gonna kind of like write it all out for us. So x to the 4th, and that's being squared, times y to the 5th, and that's being squared as well. So I'm kind of rewriting it so we can see here that now we need to multiply these exponents together. So I have negative 6 still squared, and then I'm going to have x to the 4 times 2 times y to the 5th times 2 as well. So negative 6 squared is 36, and then that's x to the 8th, and that's y to the 10th. And so notice that again, we're combining different types of power properties to kind of simplify the whole thing together. Okay. Now, we're starting to get into some more rather complex ones. And then I want to go back kind of to the beginning a little bit of this video and do some of those before we move on to negative exponents. Okay, and I'm actually going to switch markers here because then that way we can kind of see how we work through things. So now I noticed that 3 and the 4 need to be multiplied, the 2 and the 5 need to be multiplied, and the 6 and the 5 need to be multiplied. So I'm going to have x to the 3 times 4 times x to the 2 times 5 over x to the 6 times 5. And so let's calculate that. So it's going to be x to the 12 times x to the 10 over x to the 30. Now notice, these are the same bases, all of these. And I have a multiplication and a division. So I can use actually not just power, but I can use power, product and quotient to simplify this whole thing, and that's what I'm going to do. All right, so first I'm going to simplify the numerator, because keep in mind this is acting as a grouping symbol. So I'm going to have x to the 12th power plus the 10, and then I'm going to divide that by x to the 30. So what that's going to look like is x to the 22nd power over x to the 30. Again, same bases, and it's being divided, which means to say I'm going to use the quotient rule, and we're doing the bigger exponent minus the smaller exponent, and the bigger exponent is in the denominator, which means to say I need a placeholder in the numerator, and that's x to the 30 minus 22. So this ends up being 1 over x to the 8th power. So look at all that work. We are doing a lot here, a lot of really good, complicated math. Let me actually see if I can take this problem. And I'm actually going to move it down a little bit just to give us a little bit more space. We can always go back to the problems above. These are really good problems, okay? And they're super important for us to go over. So again, notice I have the 2 out there, and everything in my parentheses is being raised to all of these, okay? And I'm not going to show you all, but you get the point here. I'm raising the 10 to the 2nd power. I'm raising the p to the 3rd to the 2nd power. And then in my denominator, I'm raising the 5p to the 3rd power, meaning to say the 5 being raised to the 3rd power and the p's being raised to the 3rd power. And then the 2's being raised to the 4th power, and the p to the 5th is being raised to the 4th power. And so now I'm going to start multiplying together the exponents that are being raised to more exponents. So I'm going to have 10 to the 2nd power times p to the 3rd times 2. And then I have 5 to the 3rd power, p to the 3rd power times 2 to the 4th power. And then I have p to the 5th times the 4th. So I'm just kind of, again, writing everything out so that we are able to see where all of this is coming from. So I know that 10 squared is 100. So p to the 3rd times 2 is going to be p to the 6th. And then I have 5 to the 3rd, 5 times 5, 25. 25 times 5 is 125. And then I have p to the 3rd. And then 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So times 16. And then I have p to the 5th times 4. So that's going to be p to the 20th. Now let's do some rearranging here. I can actually multiply 125 and 16 together. So that's what I'm going to do. So I have 125 times 16, which is 2,000. So I have 100 in the numerator. That's not going to change. 2,000 in the denominator. And then I still have p to the 6th, p to the 3rd times p to the 20th. Now notice here, we have the same exact basis being multiplied together. So I'm going to use the product rule here. So I have the 100, I have the p to the 6th, I have the 2,000, and because I'm using the product rule, I'm going to add my 2 exponents. So 3 plus 20, which is p to the 6th and p to the 23rd. Again, I have here the same exact bases. So my last step is to combine that, and I can cancel some things out here. So notice little or big, small. So I have to keep a placeholder of 1, and then I'm going to have 20p